Okay, so let's look at some example problems here. Um, if we are going to find our indefinite integrals for each of these, we have to use our trigonometric identities when we are left with trig functions. So let's go back. So when we do this, you want to make sure you leave your coefficients alone, okay? And then you deal with those later when we simplify. So we can deal with each part of our integral separately. It'll make things easier for us. So the integral of 3 sine of x, okay, it's going to be 3 times the integral of sine of x. So the integral of sine of x is negative cosine of x. We then are going to subtract 4 times the integral of cosine of x, which is sine of x. Then we have to add our plus c onto the end. So our final answer, once we simplify, is going to be negative 3 cosine of x minus 4 sine of x plus c. Now, we didn't learn this one. We did not learn what the integral of tangent squared of x was. So we have to think about ways that we can deal with this. Now, as a quick refresher, there were 3 Pythagorean identities that we can use in order to help us solve trig equations. The first one we know pretty well, and that's cosine squared x plus sine squared x equals 1. Now, if you want to find the other two, one easy trick is you can divide this top term by cosine squared once, and then sine squared the second time. So if we went down, let's say we wanted to find our second. Well, we divide by sine squared of x. So our second one, so cosine squared over sine squared is going to give us cotangent squared of x. Sine squared over sine squared is going to give us 1. And 1 over sine squared is cosecant squared of x. So this is a way that we can go about creating the other identities. And this is a true statement, and you can create it as long as you know the top, which is pretty easy to read. Now, if you wanted to create the last one, the third one, we would now divide the top by cosine squared of x. Well, cosine squared of x divided by cosine squared of x is 1. And then we have sine squared over cosine squared is going to be tangent squared of x. And 1 over cosine squared is going to be secant squared of x. So in case you're in a pinch and you don't remember them, always start with the first, and then you can create the other two, just dividing by sine squared once and cosine squared the second time. Well, we only learned the integral of a few of these terms. We've learned 1. We've also learned the integral of secant squared. Okay, so we want to change tangent squared into something in terms of secant squared. So I'm going to erase this real quick. We can rewrite tangent squared as the integral of secant squared of x minus 1 dx. So these two things are exactly the same, and we can use those identities to help us out. Well, we learned earlier that the integral of secant squared of x is tangent of x. Now the integral of negative 1 is negative x, because negative 1 is the same thing as negative x to the 0, So we would have minus x to the 0 plus 1 over 1, which is the same thing as negative x over 1, which is the same thing as negative x. And then finally we have to add our plus c up to the end. So this one's a little bit trickier. So if one of those identities that I listed in the concept video, if you don't see it, you're going to have to somehow make it work using other information that you know. Okay, so let's try some other problems here. So what about the integral of sine of 3x plus the cosine of a half x? Well, what we do is you're going to take the integral of sine and cosine separately. But then, in this case only, because the integrals of the inside of these functions are just coefficients, what we're going to do is end up dividing by that same thing. So this equals the integral of sine, we learned, was negative cosine. And you got to keep the derivative, or keep the insides the same. We then are going to divide by the derivative of the inside of that function, which is 3. And we know that the integral of cosine of x is positive sine of x. So we're going to have sine of 1/2 x. And we have to divide by 1/2. Let's see. So then we're going to want to go forward and simplify. We just end up with negative cosine of 3x over 3 plus, dividing by 1/2 is the same thing as multiplying by 2, so we're going to have 2 sine of 1/2 x plus c. So you can see that if you think about this, when you take the derivative of 2 sine of 1/2 x, the derivative of sine is cosine, and then the half on the inside is going to cancel out this 2 and make it a 1, which is what we have to begin with. So you can always go back and check in case you're worried if you did it right or not. Well, let's look at maybe a little bit more complicated one. We're going to take the integral of x squared minus cosine of pi over 4 minus 7x. So we're going to deal with these separately. Well, the integral of x squared, we're going to have x cubed divided by 3. And then we're going to deal with the rest of this piece by piece. So don't do too much at once. So this is going to give us minus the derivative, or excuse me, the integral of cosine of anything is going to be the sine of pi over 4 minus 7x. We then have to divide by the derivative of the inside, or we're going to divide by the coefficient of x, which is going to be negative 7. And then we add c onto the end. So when we simplify, we'll have x cubed over 3. These two negatives are going to cancel. And so we're going to end up with a positive sine of pi over 4 minus 7x, all the way divided by 7, and then finally the plus c on the end. And so these are different examples of how to deal with the derivative, or excuse me, the indefinite integrals of trigonometric functions. The coefficients, leave them alone. Deal with them later when you simplify. Just deal with taking the integral of sine and cosine and secant squared and whatever terms that you have. Also, make sure that you are accounting for what's going on the inside. You're still dividing by that. So it's almost like that is your new exponent, like when we were doing our old trigonometric rules for integrating, or our old integrating rules. But the one difference is you don't add 1 to anything when you integrate trig functions. They are just identities, so they are what they are. You just have to know what they are, and you just simply replace them when you are doing integration.